So welcome everyone. Today we're going to be taking a look at our brand new product, MapWeave, the latest visualization tool from Cambridge Intelligence, and our first toolkit focusing on geospatial visualization in particular. Let me introduce ourselves. So my name is Bonney. I'm the product manager for MapWeave, and also speaking today we have Dan, our Chief Product Officer, who's been closely involved since the start. So let's have a look at the agenda for today. We've just released MapWeave, so everything you're seeing today is brand new. There's going to be lots more content coming out, but do take a look, keep an eye on the website. First, Dan is going to introduce some of the challenges in geospatial visualization, what the struggles are for different use cases, what different tools do well currently, and what current tools do less well, and what MapWeave is tackling. Then I'll share some demos of MapWeave and a quick tour of the site, and show you the way around. And then Dan is going to come back and talk a little bit about the tech stack and the architecture behind MapWeave, and then we'll do a Q&A at the end. So MapWeave is the fourth SDK from us here at Cambridge Intelligence. All of our toolkits focus on solving these kind of complex challenges with visualizing connected data. Our other toolkits, which you may well be familiar with, are Keylines and Regraph, focusing on graph visualization, and Chronograph, focusing on timeline visualization. MapWeave fits in really well to visualize this kind of another dimension of connected data, which is present in a lot of the data that we see, where there's a geospatial element. So it's certainly the best tool for the job in that lineup. So that's it from me on the introductions. I'm going to pass over to Dan on some of these challenges.
Okay, so yeah, thanks. Really excited to be here talking about MapWeave. It's been in the works for a while, and we're very keen to talk you through what we've been working on. As Bonnie said, there's a lot of challenges here around how you visualize complex data on maps. So I did want to start with just a little bit of background, why we built MapWeave, who is it for, what are the kind of problems we're trying to solve. I can see some people online in the webinar from a variety of different industries. Not exclusively the 6 on the screen here, but I picked these 6 as good examples of the kind of places where we see MapWeave fitting in. And the reason it fits in is because there is a lot of geolocated information across all of these sectors. So I won't go through all of these in detail, but whether we're talking about the location of a building, like a company office, which could be relevant if you're doing anti-fraud, sanctions, due diligence kind of investigations, whether it's the location of a phone call or a vehicle being photographed by a license plate recognition camera, that might be some kind of security use case. In cybersecurity, you have IP addresses, which are very easy to resolve to at least an approximate location. There are some very hot topics right now in areas like maritime intelligence, where you're looking at understanding what vessels are out there in the oceans and which are the ones you need to look closely at, and what they're up to and what they're doing. And they will have geospatial coding information about where they claim they are, and you might have other sources that'll tell you where they really are. All sorts of interesting geospatial data across all of these industries. And the world of open source OS information these days is it's just insane how much data there is out there available, in which there could be location information, anything from ad tech data to metadata in photos that tell you where a photo was taken, or people checking in on social media to particular locations. We're swamped with geospatial information. So I think that's definitely true. Hopefully you recognize at least one piece of data in this picture that's relevant to you. And if you think of any that aren't, feel free to put them in the chat as well. I'd love to hear some more suggestions of them. I think, though, a lot of this isn't new, right? And people have been visualizing data on maps for a very long time. I picked 2 examples here of map visualizations, and the one on the left is visualizing points. So basically putting pins in maps. This is where all the castles are in Europe, but everyone who's used Google Maps or Airbnb or any map with an app will know that putting points and putting pins in a map is pretty much a solved problem. The world knows how to do that. And on the right, you've got some US census data visualized with hex bins. And again, this is basically representing numerical data. So it's not pinning an individual item and saying, where is that item? But it's representing a number. What's the number of people who live in the Chicago area or something like that? So putting numbers on maps and putting pins on maps, it really is a well-solved problem. And if that was the only problem we had, then we probably wouldn't be here in this call. But the challenge comes when you start looking at more complex data, and in particular connected data. So depending on where you work, these things are sometimes called graphs, sometimes called link analysis, sometimes called network topology maps. But we all mean the same thing. We mean nodes and links, connected information. Data sources where the interesting stuff is not necessarily the item, but it's how that item connects to other things. That's really what this is about. And when you try and put this kind of stuff on a map, that's when it gets quite difficult. And there are a few challenges in particular. So we've been in the business of visualizing connected data for a very long time, and there are certain challenges that really make mapping this kind of data hard. And I think most of us have probably not seen all that much in terms of graph link analysis on a map. We might have tried to build it. We might have seen some examples of it that haven't worked so well. It's actually a really hard thing to do. So I'm going to quickly talk through those challenges, and then I'll hand over to Bonney to show you what we've built to solve them. The first one is a lot of the connections that you have are invisible when you put data on a map, because at least one of the ends of those connections often doesn't have a location. So here, for example, I've got 3 companies, and I might have a really interesting set of data that tells me who is a director of each company, and what other companies are those people connected with. And there might be some really interesting connections between these companies. But the problem is those connections have nodes which don't have a location in order to see them. So there might be a beneficial owner that all 3 of these companies have in common. And if I was looking at that on a typical graph visualization, I would see that owner. But if I try and put this data on a map, because the person doesn't have a location, what you typically get is something like this. You're back to just pins again in a map. And I'm sure if you've ever tried to load a graph data set onto a map, you've probably seen a problem a bit like this, where you're losing the geospatial context. I can look at this view, see how things are connected. I can look at this view, see where things are, but I can't see both things at the same time. And that means I'm not really understanding the geospatial relationships between companies and people. So that's a tricky problem. Sometimes, though, you do have connections, you do have links between items, and then you'll probably see challenge number 2, which is clutter, noise, generally a very ugly picture. This is what happens when you it's not even that many nodes and links. It's a few hundred nodes, and I think maybe 1,000 links or something like that, representing connections between airports here. And if I'm in well, many of those sectors I talked about earlier, let's pick a different one, like network management. So managing physical infrastructure like a wide area network or something. And I want to understand where are the problems, or a cyber threat analysis of how my different company locations are being impacted by some threat. I need to be able to understand very quickly, what do I need to see? And if putting it on a map ends up in something like this, then I can't get a sense of what's important. And this is such a common picture, because with a map, you have no flexibility to arrange these nodes in a nice, clear visual way. You can't control where the nodes are. They're dictated by location. You can't control where the links go. They're dictated by the nodes that they connect to. So these kind of hairball messes are very, very common. And again, I think it puts a lot of people off attempting to visualize graphs and connected data on maps when they try it and they see something like this. So solving that has been an even more difficult problem. And with MapWeave, we think we've cracked it, but I'll let you be the judge of it when we show you the demos. And then finally, there's a whole load of data in those examples that I showed you earlier around the use cases where there actually aren't connections directly in the data, but there are connections if you know where to look and if you start inferring things from the raw data. This is a little picture of something called AIS, which is the ship equivalent of when you see planes on flight radar and they're giving off their transponder locations. Ships do that too, and they transmit these messages. And a little dot tells you that a particular ship at least claimed it was in a certain location at a certain time. And those are not connections. That's not a graph. Those are just little observations, little time-stamped observations. These are some cruise ships out of Fort Lauderdale, and you can kind of squint at it. You do start to see there's some kind of trails and patterns. Maybe there's some common shipping lanes. Maybe there are some places ships never go. And that's where it gets really interesting, is when you start looking at the geospatially informed connections that you can infer from data. So you might be able to infer a trajectory, like a path, where a ship has been, where it's going. Even better, you might be able to infer behaviors like two ships traveling together or two ships spending time in the same location. If you can do that, then you might learn that there's a connection between two vessels based on them spending time together. And if you know that, maybe you now know there's a connection between two people who each own one of those vessels. You've now got a new connection that wasn't there before. So inferring connections from this kind of observation data and visualizing that on a map gives you even more insight than you had before. And again, that's not an easy problem to solve in general, especially because you could get millions or even billions of these data points in a typical raw data set. So MapWeave, I will cut a long story short by handing over to Bonney, letting her demonstrate it. But basically, we think we've solved these problems with MapWeave, and we think we found a way to allow you to build beautiful, interactive, clutter-free, intuitive visualizations of this kind of data and actually reveal the geospatial context of them. But let me hand over back to Bonney so she can show you what we've built.
So here we have a demo showing a global IT network. So in this kind of use case, it's important to understand that kind of high-level network overview across a really large geospatial area before maybe zooming in to interrogate that data in more detail. So you can see right from this top level that MapWeave is giving that really clear geospatial overview at a glance without either overcrowding the view or hiding any critical information. So it's using a bunch of unique MapWeave features that we've been building over time that allow users to understand that full global network without any of those kind of local distractions that can result in that kind of cluttered view. So every node in this demo has a location. So we're geolocating all of these onto the map. And out of the box, MapWeave is doing quite a lot of that work to make this view clearer and save you some of the coding effort. So if I start to play around, as you zoom in and zoom out of the map, MapWeave interprets the space that's available to present more detail about the network as there's room. So we've been grouping nearby nodes together to reduce the crowding when there's not enough room to show them. But you can see as I zoom in further, here over in the UK, these combined geographic nodes split apart onto their correct locations on the map. So you'll also start to see more detail appearing. So we've got link labels, all because MapWeave is interpreting the space, the zoom level, the amount of data that I'm looking at, to just provide more insights without overwhelming the user at every single zoom level, at every single geospatial area of the map. Here we're also using country level polygons to overlay the worst case performance coloring onto the map, again, making those insights really clear no matter what zoom level you're at. So we've put quite a lot of time into these different intelligent choices about what to show at every zoom level, avoiding clutter, presenting the right messages so that users don't get overwhelmed. They get this geospatial overview of the global network without having to either navigate a load of messy stuff or hide any critical details that you might actually need to understand that kind of local level picture. So that's the first excitement. Let me keep going. So here, moving use cases again onto a cyber threat intelligence demo. Here we have far too many nodes to show them all at once at this global view. The geospatial dimension of cyber threats is often overlooked, but it can reveal powerful insights into the threat landscape, such as like geopolitical effects or the sources of an attack, or in this case, the global spread of different malwares over time. So in this demo, we have a mix of geographic nodes and non-geographic nodes. So the malware themselves aren't located anywhere specifically on a map. In theory, these non-geographic nodes could be positioned anywhere on the map, but MapWeave is cleverly positioning them appropriately relevant to the nodes that they're linked to. So depending on what I have at any point in time on the map, it's putting them to give the best view of the data. MapWeave's able to prioritize this kind of global structure and play down the local structure at this level of zoom until I start to zoom in far enough on any of these particular countries to see more of that local structure once there's room for it to appear. So MapWeave, again, is understanding my zoom level, my view of the data, and considers how it should be presented to show users important information without any distracting clutter or overwhelming amounts of detail. So to do that, MapWeave is looking at those most important nodes. So in this case, the malware, and they've been sized to kind of stand out at that global level. They've got connections right across the kind of global view. But then zooming in further, we've got these white nodes, which are kind of country level and sized accordingly. And then the smallest nodes appearing as the individual attacks. And MapWeave revealing even more detail, such as the node labels as you zoom in. This demo also brings in the concept of time alongside a geospatial network. So the time bar down here shows you the volume of data across all malwares over time. But if I click on a particular one, you can see the spread of that particular malware over the period of time, and you can also kind of select a particular period of time to investigate for one or many malwares. So that's introducing some more new concepts, time, and how we handle those non-geographic nodes. But I'm going to keep moving up in terms of volume of data and moving on to the next demo. So in this demo, we have a fictional network of sanctioned individuals and some companies and some high value assets that they're associated with. Again, it's another really large network that could get very messy very fast, especially with that mixture, again, of geographic nodes, locations of offices, locations of assets, and non-geographic nodes like these people who are associated with multiple things over here. So for this kind of investigation, MapWeave adds a new dimension to link analysis with these unique kind of graph layouts and really powerful adaptive behaviors that work with any combination of geolocated and free nodes or non-geo nodes. You can see if I zoom in that we've got this company in London. Again, more detail becoming visible as room on the map becomes available. And that company has this kind of local structure that includes some geo nodes. The companies have offices in different locations, and some non-geo nodes, some employees of this company. And then zooming out, that local structure collapses, but the global structure still becomes clear. So I'll zoom back out and pull in some more information, and you can see that this company owns some assets, such as yachts in this case, and some people over here. This person has multiple companies in common, one in London and one over in the US. So MapWeave is doing all the heavy lifting to visualize that detail that matters, depending on the zoom level the details viewed at. At a high level, that global view is simple, not overwhelming, but still provides some clear insights about the general structure of the network, the key nodes, and the location of those geographic nodes. But then at the local view, we've got the dense clusters of nodes. For example, if I go back in over here, so here's another dense cluster in Europe, which was combined at the high level view, but gradually splits apart as I zoom in, and more space on the map is available to reveal that complexity and reveal that detail on a local level. So MapWeave's layout really cleverly retains that position of the geographic nodes, no matter what zoom level you're at, but then bringing in further detail about the non-geographic nodes and putting those in the right place on the map. Also, the general position of these non-geographic nodes is preserved as you zoom. So even as I zoom in and zoom out, there's no sort of jumping around of non-geo nodes or any unexpected movement. Things kind of feel natural, they're sized naturally. There are all these subtle improvements that make it feel smooth and performant rather than kind of any unexpected movement, even if these non-geographic nodes could be anywhere on the map. So I'll keep on going and move up again in dataset size. So here I wanted to show you some clever bundling and heat mapping in MapWeave to visualize sort of flows between nodes. Here we're showing over 4,000 different flight routes across the US. And this demo shows many of the features that I've already shown, but it also showcases some of the kind of clarity that MapWeave can provide in really tangled geospatial networks, like Dan was talking about, allowing you to kind of simplify that picture at the global level, but also using the powerful features to provide detail about particular connections on demand. So you're selecting the data that's important to your analysis. So if I turn off these features and go back to a kind of a standard network view, you can see that this is a pretty large, heavily connected network. You can't derive any clear conclusions from this view. Flights are all crossing over each other, creating this kind of a hairball. And it's hard to see even where individual airports are at this global level because they're all clustered together. You know, I'm getting an overwhelming amount of information in this view. And I can't move any of these nodes about either to clarify my view like you might be able to with a non-geographic graph, because all of these nodes are airports and they all have geographic positions that mean something. So by turning on that adaptive opacity, we can already see some improvement. So MapWeave is now using some user-defined metrics based on that graph structure to create a node priority. So this clarifies that global picture, it simplifies things, it becomes less overwhelming, and it shows users the most important flows or routes without changing the shape of the links themselves. So if that shape of link is really important, then this keeps that there. As you zoom in, you can start to see more detail again become available on smaller airports and different routes that weren't important at that global level. And you can get down to this kind of local view. If you then click on an airport, all of its associated routes will be highlighted while keeping the rest of the data set sort of visible, but not in an overwhelming way. Clicking away from that and turning on MapWeave's sort of powerful link bundling, this is the really powerful thing that can present those messages, I think, in an even better way. So MapWeave changes the paths of the network to show a much tidier picture and start to present you with more of a heat map view, a kind of summarized network. We're not showing every single flight route. We're not showing you that tangle of links because that would be overwhelming, but we're summarizing the kind of overall flow and showing you that full data set in more of a heat map. So we avoid overwhelming users by trying to convey everything in one screen, but instead provide some clear high-level messages at that global level. So you can see some of the busiest routes in this northeast area over here, and key connections between major airports. I get more information on these tooltips on Hover. But MapWeave is making it possible to navigate these really complicated geospatial networks to pull out the messages and do the analysis that users need. So moving on to our final demo and our biggest demo before I give you a quick tour of the site. I'll just let this load up to show you how much data's in there. Here we've got our biggest data set of 240,000 data points, but we've actually tested MapWeave with over 1 million data points, and it's still really performant, still runs really smoothly. So if I zoom in, you can see that we have each of these individual observation points, and I'll talk a bit more about what these are. So this data set is made up of all these individual observation points represented as these small green dots, along with a set of observations we've highlighted as orange alerts, representing some unusual behavior that we may want to look into later. So all these AIS observation points are from about a week's worth of marine traffic around the US coastline. And these kind of data points are not part of a network. Let me close this. They're not part of a network, but they are data points that happened at a certain point in time, at a certain point in the world on the map. And then on the time bar down here, we're showing the observations in the green series, and the red series showing that alert volume that we've identified. It could be a potential ship-to-ship transfer. So MapWeave is great at understanding this kind of flow, whether it be maritime, whether it be other kind of movement patterns. It really excels at these kind of use cases where there is a need to not only track the movements of the vessels from data sources such as AIS feeds, but also to understand typical behaviors and then spot when something unusual is happening. So if I zoom back out to that global view, and we can see the full data set, and then press the play button on the time bar, you can see all these individual ships, which are represented as the white dots, moving through time along each ship's observation points. So you can see it's pretty fun and performant at this kind of zoom level, and it's all very interactive, and you can start to investigate and get a kind of a clear view of things before you dig into the analysis. But then what's interesting is we're interpolating between these data points to calculate these paths between individual observations. And we call these a trajectory in MapWeave. And we're inferring those based on the observations themselves and the timestamps. So working out when ships are moving between A and B. I'm not sure how it was coming across on the webinar, but it's really performant playing this data at this large scale. And these kind of animations can bring the data to life before digging into anything deeper. So these trajectories are a unique value add in MapWeave that are much clearer than simply visualizing the raw observation data points as those individual dots. So clicking on any of these vessels or an individual observation point highlights the trajectory for that vessel. So you can see some additional details if I open back up the sidebar, some additional details about the vessel, but you can also start to see some interesting things at this level. You might see a broken observation like here, where a vessel has turned off its tracking data and this trajectory ends, but then restarts once tracking is turned back on. And you can also take a look at the time bar and see this kind of concept of now with where that node is at a selected point in time. So if we put things into practice, where things get really interesting is the analytics side, being able to go from a very high level down to a very detailed level, and then communicating the story or the narrative behind it. You can see that right now we've got the ship at this point in time. We're using these kind of tracker nodes. So these are larger nodes that represent where that exact vessel was along its trajectory at that particular point in time. So you can start to associate the entity, the node, with its geospatial location, with its point in time over here on the time bar, and you can interact with this in various ways. You can play around with the tracker node itself and drag it to where you're interested in. You can drag the time bar to the point in time where you're interested in, or you can zoom out and look at that trajectory in more detail. So if I go back out to that full data set view and dig into the analytics for the final section. So looking at these red alerts, we could be looking at something like a ship-to-ship transfer out at sea and a ship spending a lot of time in one place. So we've identified these observations in red as a particular alert, ship-to-ship transfer. And if I click on one of them, you can see the two ships involved in that event. There's an identified co-location of two ships, and you can see we've got the two tracker nodes here, which they travel together for a period of time, and then they split off on their own individual trajectories. So in this view, I've got that simpler view just for analysis of those two ships of interest and following their movements exactly. I might want to see where they started out, how long they were together, and then where they ended up. And again, I can play the time bar back to that particular point in time. So you can see where they started out and how long they were together, and then where they went off again afterwards. So that is that. It's all very interactive and explorable. I'll just run you through 1 minute of looking at the site itself. So what I've been showing you is our demos on the site. So we have these across all our products. These are our fully functional kind of different use case demos, and you can see these across the MapWeave site. But then the best place really to start looking at features is this examples page. So this will show you live examples of all of our different features, and you can open them up. You can see the code. We share the code for these, and you can also open that code in the playground and start to edit it yourself, or take that code out into your own application. And then just like on our other sites, we have some docs. Dan is going to talk through this diagram in a moment. So you can start to have a look at the docs. But I would say the main thing to start playing around with is these examples. Take a look at each feature in more detail. So that's it on the demos. And I think I'm going to hand back to Dan for a quick look at some architecture and
yeah, that's a quick tour of what we can do. What I'm going to do now is just say a little bit about the tech stack. I don't want to get too involved in this. We're happy to take questions afterwards or post them on the chat. But there were a couple of really key points, I think, that we've been trying to address with MapWeave that I did want to mention, and they're to do with two things. One is scale, and one is flexibility of mapping solutions. So top left is an example Bonney mentioned. I think it was 250,000 observations in that maritime demo. This was 1.4 million, I think, observations in another data set, which is looking at the velocity and position of taxis in Portugal. And it's a little hard to get this across in a web meeting, but it's very performant, very interactive. You can filter the data in real time, and we're doing that through leveraging technologies like GPU acceleration and some nice efficient data modeling in there. How does MapWeave scale beyond that? That's when it gets kind of even more interesting. If you're looking at giant data sets of a year's worth of observations, when you're getting into the billions of nodes, we're very keen to work with customers who are doing that kind of scale problem to understand exactly how we can deal with incremental loading, which data you load when, how you update these things in real time. But the performance is pretty fantastic, and it's one of the reasons we developed MapWeave as a brand new tech stack rather than building on one of our existing products. Is we want to be able to deal with these very different kinds of data sets where you're getting this millions of observations kind of information loading in. This is all running in the browser. It's pretty nice. And then bottom right is an example of, I think that was one of our developers who went skiing and recorded his GPS trajectories. But I wanted to show an example. This is a Google Maps 3D tiles tiling assets, and I think the key thing here is that there's a huge ecosystem out there of different mapping products, different tile providers. There's raster tiles, there's vector tiles, there are different base map libraries. You might have seen Mapbox in the demos Bonney was showing. There's a little Mapbox logo there. We really don't want to be in the business of recreating the world of actually doing map projections and map tiling. That's a solved problem. There's a lot of people doing it already. Our focus is purely on that kind of information layer where we are taking this complex connected data and presenting it in a compelling way on the maps you're already using. So the idea behind MapWeave is a very, very kind of flexible open model. Basically, you down here at the bottom, you're loading in your data, the nodes, the links, the observations. You're also loading in whatever map tiles and assets you want, and you can do that directly. You can point MapWeave at a set of map tiles, or you can use one of our adapters. So we provide a number of adapters for libraries like Mapbox, and you can connect that way. And what MapWeave is focused on is taking that data, creating these higher level visualization layers, and as the name suggests, weaving them together and putting them on the maps of your choice, so that you can build these interactive applications. It's a really nice architecture. It gives people a lot of freedom. We would love to hear more from people on what mapping libraries and environments they need to support. Are there particular mapping data services you need? Are you doing kind of your own custom layers? But the design is pretty flexible, and it'll allow you to do things like work with self-hosted tiles if you need to go fully offline for defense and security applications, and it'll let you work with the hopefully the data providers you're already using and the mapping tiles you're already using, so that you can get the best of both worlds, really, and show this complex data with the context that your end users are familiar with. So that's probably all I wanted to say on the architecture. Just wanted to give a little bit of background on it. Obviously happy to take more questions on it afterwards, but I think with that we'll probably wrap up.